Units, units, units. That is the theme of this IXL video. So the first part, we're going to go over customary units. We'll go over metric units. Then we'll go over the units used to describe temperature. So first thing that we need to go over is the difference between customary unit and a metric unit. So customary unit is listed all here in black in this first column, and metric unit is listed here in the right in purple. So for volume, or how much space something takes up, customary units typically are used as pints, cups, quarts, and gallons. Typically speaking, this is for liquids whenever we describe volume. For metric system, the units that are used to describe liquids are typically milliliters and liters. For length, to describe how far something is or how long something is, customary units, they use inch, feet, yard, and mile. Whereas for the metric system, in order to describe length, they use millimeter, centimeter, meter, and kilometer. Last but not least, for mass, we have ounces, pounds, and tons. And on the right side, we got milligrams, grams, and kilograms. So one of the important reasons why scientists use the metric system is shown on the next page. So one of the big reasons is that in order to convert or to go from one unit to another unit, every single unit in the metric system is going to be converted and changed in some factor of 10, which makes it relatively easy to remember the conversion numbers and how to change from one unit to another. Whereas in the customary unit, if you want to change from, say, for example, quarts to gallons, you have to remember that the number 4 quarts is equal to a gallon to do that conversion. If you want to do it for inches to feet, you have to memorize the number 12 inches is equal to a foot. Whereas for the metric system, if you just remember that 10 milliliters equal to a centimeter, you can use the same logic for volume and mass. So for example, 10 millimeters is equal to a centimeter, 10 milliliters is also equal to 1 centiliter, and 10 milligrams is equal to 1 centigram. You can use that logic consistently throughout, which makes it easier. First things first, I want to go over some examples of customary units. So if you're a little unfamiliar with approximately how much that customary unit is describing or how much it is, this chart here will be very useful to you. 1 cup, most students are fairly good to go with. So 1 cup is just like a cup of water. 1 quart, if you've ever gone to the store, you've probably seen like a quart of milk. And for a gallon, most have seen a gallon of milk at the store. For the length of an object, 1 inch is roughly 1/2 of that of this eraser. For 1 foot, it's roughly the size of a men's shoe if it's 11 inches. Keep in mind that shoes typically are 1 extra inch to give it a little bit cushion space so that the foot is able to fit into the shoe. And then for a mile, I believe at school it's roughly about 3 or 4 laps, give or take, in order to complete a mile. For mass, the 1 slice of bread is roughly equal to an ounce. For 1 pound, roughly 1 can of soup is equal to a pound. 1 ton is roughly equal to that of a compact car. Now, for the metric units, since most students are not as familiar with this, I was going to go through one section at a time. So once again, volume refers mostly to liquids and how much space it takes up. So 1 milliliter is equal to about 20 drops. So doing teardrop dropper 20 times will get you about a milliliter. 1 liter is equal to half of a 2-liter bottle. Most typical soda bottles are 2 liters, so half of that would be a liter. 1 kiloliter is roughly 1,000 liters or 500 soda bottles. Another way to think of it is, roughly speaking, like those hot spas or jacuzzis or like those mini pools you see, they're roughly in the ballpark range of about 1,000 liters or 1 kiloliter. For length, once again describes distance or how far something is or how long something is, the thickness of a credit card is roughly that of 1 millimeter. For 1 meter, it's roughly a little bit over 3 feet. So I just had a picture of a person's foot there. And 1 kilometer is a little bit more than half of a mile, which is the reason why I reused that picture for this diagram there. For 1 milligram, it's 1/10 a grain of rice. So if you took 1 grain of rice and you chopped it into 10 pieces, that's roughly 1 milligram. 1 gram is equal to the mass of 1 paperclip, and 1 kilogram is roughly the mass of a big textbook. So once again, when you're going through those estimations to determine the rough unit calculations for everything, this chart may be very useful to you as you're going through that section. And now we're going to go to estimating temperatures. We're going to start off with degrees Celsius because the boiling point and freezing point of water is fairly recognizable to most students. Degrees Celsius is based off the melting point and boiling point of water. So the freezing point of water is set at 0 degrees Celsius and the boiling point of water is at 100 degrees Celsius. So that's a very good reference point. Now, on the flip side, when we're talking about degrees Fahrenheit, its degree and scale system is different from that in degrees Celsius. So for comparison's sake, 32 degrees Fahrenheit is equal to 0 degrees Celsius, and the boiling point of water, which is 100 degrees Celsius, is equal to that of 212 degrees Fahrenheit. So just to give you that comparison, just so you know how much it is in the other unit. Now, we're going to go through some various examples just to give a better idea of how much it is for each unit for degrees Celsius and degrees Fahrenheit. So once again, the freezing point of water is 0 degrees Celsius or 32 degrees Fahrenheit. Room temperature, so the temperature of a room that most people find comfortable is roughly 70 degrees Fahrenheit, which is approximately 21 degrees Celsius. Hot day for people in California is roughly 100 degrees Fahrenheit, which would be 38 degrees Celsius. The temperature for water in order to have it kill bacteria, this is especially important for people in the food industry who's cleaning up plates and etc. The liquid in the water needs to be at a minimum of 140 degrees Fahrenheit, which is equal to 60 degrees Celsius. Once again, the boiling point of water is 212 degrees Fahrenheit, which is 100 degrees Celsius. And last but not least, fire burning, roughly speaking, when it's in the red color zone, it's going to be approximately 600 degrees Celsius, which is approximately 1100 degrees Fahrenheit. So once again, when you're going through that section, it might be good to have this as a reference so that you have a good idea of, roughly speaking, where the temperatures will lie.